Over the past 50 years, the frequency of natural disasters worldwide has increased fivefold. We can be certain that another catastrophic event is approaching our planet. During the last half-century, these disasters have claimed the lives of more than 2 million people. Seismic events that once seemed manageable have caused the deaths of approximately 150,000 individuals. Storm systems have taken more than 500,000 lives. Meanwhile, flooding and extreme temperature variations have claimed nearly 115,000 lives. Furthermore, this year, the largest oceanic current formation, the Gulf Stream, along with Earth's core, may cease functioning. These events are not merely isolated incidents. Our planet has already experienced 5 major mass extinction events. All evidence indicates that today, humanity stands on the threshold of the next one. Perhaps it has already begun. Although the greatest extinction events in Earth's history are called mass extinctions, they did not eliminate 100% of living organisms. A certain percentage of species always survived, evolved, and repopulate the planet. Therefore, there exists hope regarding the minimum number by which human population could decrease following a mass extinction event without disappearing completely. To find the necessary figure, we must examine the past. Approximately 74,000 years ago, in the territory of modern-day Indonesia, the Toba supervolcano erupted. As a result, the volcanic winter that accelerated the onset of the Ice Age caused the deaths of many animals and plants. Most frightening was that the extinction event affected humans as well. During that period, the number of Homo sapiens may have decreased to 3,000 individuals. This process is called the bottleneck effect. Starting with such small populations, the future trajectory on the graph leads either to recovery or complete extinction. Since you are currently watching this content, you have already guessed that humanity did not disappear at that time. Therefore, if during the next extinction event, at least 3,000 people remain on the planet, our species has a chance to survive. But what exactly threatens us? The first thing that comes to mind after hearing mass extinction is the impact of a giant meteorite, similar to the one that eliminated the dinosaurs. It triggered the Cretaceous-Paleogene extinction event that occurred 66 million years ago. At that time, approximately 75% of plant and animal species disappeared from Earth. That asteroid was simply enormous, about 10 kilometers in diameter. This is 3 kilometers larger than the tallest mountain on Earth, Mount Everest. Meteorites typically travel at speeds of approximately 20 kilometers per second. During Chicxulub's collision with Earth, approximately 72 teratons of energy were released in TNT equivalent. This explosion was nearly 5 billion times more powerful than the atomic weapon dropped on Hiroshima. However, the devastating impact was not only the asteroid strike itself, but what happened afterward. Dust particles that rose into the atmosphere literally prevented solar rays from reaching Earth's surface. As a result, photosynthesis ceased in plants and algae. They began dying, and most animals on the planet were left without food. During the Cretaceous-Paleogene extinction period, all non-avian dinosaurs completely disappeared, along with most animals weighing more than 25 kilograms. Together with them, ammonites and many other mollusks, plesiosaurs and mosasaurs perished, as well as all mammals that were exclusively herbivorous or carnivorous. However, small mammals that fed on insects or carrion managed to survive the meteorite impact. But what about humans? Would we survive the impact of Chicxulub's twin today? Imagine looking out your office window and seeing a massive fireball wrapped in flames approaching you from the sky. What would you do? How would you save yourself? These are the last thoughts you would reasonably have before perishing. Scientists calculate that due to the extraordinary high temperature, all living organisms within a 1,000-kilometer radius would literally turn to ash even before the asteroid's impact. For example, if Chicxulub 2.0 struck directly over Manhattan, approximately 105 million people would perish before the collision itself. If it fell on London, about 100 to 103 million people would be vaporized alive in one moment. But let's assume the asteroid strikes the exact same location as 66 million years ago. In the first seconds from thermal radiation, nearly 3.7 million people would die. Forests within 1,000 kilometers around would be engulfed in fires that would subsequently spread across North and South America. The crater diameter at the impact site would reach 303 kilometers, similar to the state of Rhode Island. At the moment of collision, an unimaginable amount of energy would be released. Approximately 70,000 cubic kilometers of rock would simply vaporize. For comparison, this is 18 times larger than the volume of the Grand Canyon. Just 15 minutes after impact, this rock would begin condensing again and transform into molten ash. Additionally, Chicxulub 2.0 would trigger an earthquake with a magnitude of 10 to 11 on the Richter scale. It would likely be felt from Colombia to Kansas. Furthermore, the impact would cause tremendous wind gusts reaching 1,000 kilometers per hour. These would overturn vehicles and destroy buildings within a 2,200-kilometer radius. Combined with the super-powerful earthquake, this would lead to the deaths of nearly 350 million people. But that's not everything. Following the earthquake, a tsunami would inevitably appear. In this case, the catastrophic waves would reach 1,500 meters in height. The tsunami would reach the coasts of Europe, North Africa, Greenland, and even New Zealand and Australia. It would be 30,000 times more powerful than the deadly tsunami in the Indian Ocean that caused the deaths of approximately 230,000 people in 2004. If the Chicxulub scenario repeated in our time, the giant wave would claim at least 34 million human lives. But the worst lies ahead. The enormous amount of ash that would rise into the atmosphere after impact would plunge the world into twilight lasting 3 years. You might think such darkness cannot eliminate you directly. Perhaps not, but it would destroy most plants on the planet. Along with them, all domestic animals would perish. The endless night would gradually exhaust all food sources and lead to the deaths of 70% of living beings on the planet, including humans. The darkness would bring sharp cooling as well, which would also claim many lives. The chaotic and catastrophic reduction of human population and civilization's collapse following Chicxulub 2.0 would mean medicine could not effectively control diseases. The first at risk would be people with chronic illnesses. According to statistics from the Centers for Disease Control and Prevention, this represents more than half of the U.S. population. As a result of the giant asteroid impact, Earth's human population would decrease by more than tenfold. This is still a relatively optimistic prognosis. The good news is that humanity would likely survive mass extinction. The bad news is that such a scenario appears quite realistic. In 2020, asteroid Apophis passed critically close to our planet. Fortunately, concerns about potential collision were not confirmed. However, if such an object struck Earth, the impact force would equal several hundred megatons. This is 10 times more powerful than the most powerful nuclear weapon ever tested. But asteroids are not the only threat of mass extinction from space. Let's travel back 445 million years. Earth looked completely different then. The supercontinent Gondwana was just forming. At that time, when the first plants were just beginning to appear on land, marine life was developing at unprecedented rates. During the Ordovician period, the so-called Great Ordovician biodiversification event occurred, when the quantity and diversity of marine species increased many times over. Who knows? Perhaps life would have continued developing underwater until today, if not for. Actually, scientists are still not certain what exactly caused the Ordovician Silurian extinction, one of the most massive in history. At that time, 85% of marine species disappeared from the planet's surface. This represents almost half of all animal world genera. The losses in the ocean were enormous. Scientists have several hypotheses about what could have caused this extinction. One of them is a supernova explosion. But how could a star from distant space eliminate 5/6 of all life on Earth? And how can a supernova cause human extinction? In 2002, researcher Adrian Melott from the University of Kansas published findings in the journal Astrobiology proving the direct impact of supernovas on terrestrial organisms. The scientist examined ocean floor samples collected from various corners of the world. In each of them, he found iron isotope, iron-60. This is a radioactive element with a half-life of 2.6 million years. Since our planet is already 4.5 billion years old, this iron isotope should have completely decayed. So, where did it come from? The fact is that iron-60 is created during supernova explosions. Therefore, Melat and other scientists believe that approximately 2.5 million years ago, at a distance of 150 to 300 light-years from Earth, a supernova formed. Due to this, radioactive iron deposits can still be found on Earth. Now imagine such a star exploded much closer. Say, just 30 light-years from us. At such a distance, the first thing we would notice, besides the beautiful picture in the sky, would be bright blue light. It would not disappear day or night for a month and would interfere with melatonin hormone production. This hormone is responsible for the sleep process in humans, but insomnia would not be our biggest problem. Together with light, a gamma-ray burst would reach Earth. These cosmic rays ionize air, knocking electrons out of atoms. This creates charge differences and forms lightning strikes. They would cause massive forest fires across the entire planet. North America and parts of South America would suffer most. Europe, North Africa, and Asia would also be affected. Besides direct damage from fire, humanity would face long-term consequences. Due to burning, large amounts of carbon dioxide would be released into the atmosphere. For example, during the 2016 fires that affected 20% of Amazon forests, approximately 31 million tons of CO2 were released. This is roughly the same amount Denmark releases into the atmosphere annually. Now imagine how much carbon dioxide would be released if all forests burned. We would have high chances of repeating Venus's fate and becoming the hottest planet in the solar system. However, humanity would need to survive until then. The fact is that gamma radiation would not only cause catastrophic lightning around the world. The supernova burst would send a stream of muons to Earth, unstable elementary particles. Their impact on human organisms could be compared to several computer tomography scans in succession. In addition to this X-ray radiation that would irradiate Earth after the gamma burst could destroy the ozone layer. This would leave us without protection from ultraviolet radiation. We would face threats beyond simple sunburn. DNA mutations and cancer would affect millions of people. Our ancestors lived in Ordovician period oceans. Nevertheless, humanity would most likely survive such an event, though it would decrease tenfold. Scientists still debate how close a supernova must explode to cause mass human extinction, whether 30 or 300 light-years from us. Currently, the closest star to Earth that could transform into a supernova is Ike Pegasi. It is located 154 light-years from our solar system. True, this event might occur in approximately 2 billion years. That's relatively soon, considering the universe's scale. But before space threatens us, humanity might be eliminated by Earth itself. Approximately 200 million years ago, our planet experienced the largest extinction of the Mesozoic era, the Triassic-Jurassic. Then, reptiles almost completely disappeared. Except for pterosaurs and dinosaurs, amphibians, and the entire class of conodonts, creatures resembling eels. Overall, about 75% of animal species became extinct. The cause of this catastrophe was not supernova explosions but air. More precisely, volcanic eruptions that changed its composition. During the Triassic period, in the very heart of Pangaea, was located the so-called Central Atlantic Magmatic Province. This area covers 11 million square kilometers, through which 2 to 60 million cubic kilometers of magma could pass. Scientists believe that precisely due to volcanic processes in this region, large amounts of carbon dioxide, sulfur dioxide, and toxic mercury were released into the air. The concentration of greenhouse gases increased from 1,000 parts per million to 4,000. For comparison, in 2022, greenhouse gas levels in the atmosphere reached a record 420 parts per million for modern times. The largest and fastest carbon dioxide release in Earth's entire history during the Triassic extinction led to catastrophic consequences. Global temperature on the planet increased by 4 degrees, and in some places by a full 10 degrees. This primarily affected plants. According to various calculations, during the Triassic-Jurassic extinction, 17 to 73% of their species disappeared. Following plants, herbivorous animals began dying en masse. Predators followed them. Simultaneously, oceans experienced their own apocalypse. Due to volcanoes, sulfur dioxide levels increased in water. This changed ocean acidity, which, combined with temperature increases, destroyed coral reefs. Oxygen reduction affected all other underwater species as well. How devastating would such an extinction scenario be for humans? According to biologists, approximately 800 million people worldwide depend on oceans. If most marine animal species become extinct, they would simply starve to death. Heat would cause no less damage. Temperature increases in regions located near the equator would threaten at least 20 million people. But this would only be the beginning. Already today, one person dies from hunger every 4 seconds. This amounts to approximately 9 million deaths annually. Imagine how much these figures would increase when 3/4 of crops die due to carbon dioxide emissions. Additionally, toxic volcanic gases and mercury vapors released into the atmosphere during eruptions would harm residents of former Central Atlantic magmatic regions. Today, these areas are scattered across different continents: Central Brazil and Eastern South America, parts of North and Central America, several European countries, and Western Africa. Fortunately, humans are not currently threatened by a global volcanic catastrophe. But don't rush to celebrate. This is not the only source that could destroy us. Geophysicist Daniel Rothman believes that by 2100, carbon dioxide levels in oceans will increase by at least 300 gigatons, approaching the catastrophe threshold. Rothman's research showed this would be sufficient for a new mass extinction to begin. True, it would last approximately 10,000 years. But there is something capable of eliminating humanity much faster. It seems this extinction process was triggered in 2006. The most powerful mass extinction of all time is considered the Permian Triassic, which occurred approximately 250 million years ago. Then, 96% of animal species disappeared. Ocean dwellers, vertebrates, and even insects suffered most. The largest insects that ever existed became extinct then. Trilobites and sea scorpions also disappeared. What could have caused such massive destruction of living beings? Scientists consider several versions and even their combinations, but among them, the methane hydrate gun hypothesis appears most frightening. The fact is that ocean and sea floors can store so-called methane hydrate, water ice containing large amounts of methane. Additionally, this gas, like oxygen, can dissolve in water. For methane to remain in solid frozen form, the correct balance of pressure and temperature is required. As you probably guessed, this is quite easy to disrupt. Chemical engineer Gregory Riskin calculated that during the end of the Permian period, oceans could have stored approximately 10,000 gigatons of methane. To trigger catastrophe, a single push would suffice. At the beginning of the Permian extinction, there were enough such triggers. At that time, the so-called Siberian traps became active, magmatic rocks covering 7 million square kilometers. Fractures in them can erupt enormous volumes of lava. These volcanic processes raised ocean temperature and destabilized methane hydrate, releasing gas dissolved in water. This could have changed water pressure, releasing even more methane. The catastrophe would then be unstoppable. Riskin claims that methane mixed with air can create an explosively dangerous mixture. These deadly clouds would travel deep into continents. A single lightning strike would be sufficient to detonate such an atmospheric bomb. Scientists believe these explosions were not only dangerous themselves, but also caused massive fires. Paleontologist Gregory Retallick believes the Permian Triassic extinction was not so dramatic. He notes that most creatures then died from altitude sickness. The reason is that methane release into the atmosphere made air as thin as at 4 kilometers altitude. Animals did not die from suffocation, but due to low oxygen levels, they developed cerebral and brain edema. According to Retallick, only creatures with large hearts and well-developed chest cavities survived the greatest extinction. This allowed them to breathe more efficiently and adapt to new conditions. For humans, such oxygen concentration changes would also represent catastrophe. It seems we have no future choice but to prepare for methane apocalypse. The fact is that methane is natural gas. It is released both from human activities and, for example, from tropical swamps. Its quantity can increase, but only to a certain mark where absorption and production compensate each other. However, researcher Ed Nisbet noticed that in 2006, methane concentration unexpectedly began rising. By 2020, methane emissions into the atmosphere accelerated so much that they broke all records. Worse yet, scientists are still not certain why this is happening. One version suggests expanding swamp territories. But swamps could not have increased so dramatically since 2006. This map clearly shows how many methane hydrate deposits exist in oceans. What if one of them is disturbed by an earthquake? Or an abnormally warm current? What if a chain reaction is triggered at any moment? If methane outlets suddenly release their contents, coastal residents would suffer first. Immediately, approximately 2.5 billion people living directly near catastrophe sites would perish. Then, explosive mixtures would travel deep into continents and cause massive forest fires, whose consequences we already know. Simultaneously, thinned air would cause painful deaths from cerebral edema or brain swelling. People living at altitudes of at least 2,500 meters would have better survival chances. This represents slightly more than 1% of the population. However, it appears that even under this worst-case scenario, humanity would have a chance to survive mass extinction. After all, 27.5 million is 9,000 times more people than survived after the Toba volcano eruption. It turns out we have a real chance. Unless, of course, we overlook something important. People surviving mass extinction would find themselves in extremely difficult conditions. They would need to learn to obtain food through hunting, protect themselves from post-catastrophe consequences, and survive in a world without medicine, transportation, internet, and communication. But most importantly, be careful with those around you. After all, one of the recent extinctions, the Quaternary, during which mammoths and giant ground sloths disappeared, was caused precisely by humans.